Sign up for CNN's Wonder Theory Science newsletter. Explore the universe with news on fascinating discoveries, scientific advancements and more. CNN, the Curiosity rover just avoided a near run-in with some razor-sharp rocks on Mars. The robotic explorer, which landed on the Red Planet nearly 10 years ago, has spent the last month climbing the Greenhue pediment on Mount Sharp, located at the center of Gale Crater. The Greenhue pediment is a large sloping plain that NASA rover drivers were going to use to reach other targets. But the rover pulled up short when it spied continuous stripes of knife-edged rocks, dubbed gator-back terrain due its scaly appearance. Typically, NASA's Mars Reconnaissance Orbiter can help Curiosity prepare for encountering hazards because its high-rise camera can spot objects the size of a basketball on Mars as it whirls around the planet. But these rocks were just small enough to evade the Moreau's watchful eye, said Ashwin Vasavada, Curiosity's project scientist at NASA's Jet Propulsion Laboratory in Pasadena, California. These rocks, known as Ventifax, are wind-sharpened rocks, and Curiosity has had a previous run-in with Ventifax before. Early in the missions, Curiosity's wheels suffered some wear and tear after rolling over them. But there are more of these Ventifax in the field Curiosity came across on March 18 than the rover has ever encountered. They're made from sandstone, the hardest rock found by the rover on Mars to date. Ventifax previously caused some damage to the rover's wheels, as seen in this photo from March 2017. It was obvious from Curiosity's photos that this would not be good for our wheels, said Megan Lynn, Curiosity project manager at JPL, in a statement. It would be slow going, and we wouldn't have been able to implement rover driving best practices. The rover team on Earth has found ways to drive on more benign terrain on Mars to preserve the rover's wheels and lengthen its lifespan, avoiding anything that might damage them. The sandstone has been abraded by blowing sand for many years, sharpening the tops of the rocks into facets, Vasavada said, and Curiosity's trek would have it driving over them for about a mile. It wouldn't necessarily kill them, but it would wear the wheels down at the same rates that scared us earlier in the mission, he said. The way the rover drives, which is essentially like steering to turn the wheels of your car in the parking lot before stepping on the gas, means that Curiosity's wheels would have ground against the carpet of pointed rocks, which could cause the rover to get stuck. Had Curiosity tried to weave through sandy troughs between the ridges, it would have sent the rover on a long, meandering maze-like journey. Seeking Martian secrets, the rover began ascending the 3.4-mile-tall, 5.5-kilometer-tall mountain in 2014. Throughout this journey, Curiosity has been able to study different layers that show the Martian climate record and when it went from wet to dry billions of years ago. The bulk of Mount Sharp is kind of a horizontal layer cake that built up over time, Vasavada said. The bottom layers of sediment were deposited by rivers and streams, dumped into a lake that likely filled Gale Crater billions of years ago. When that mud settled, it became the foundation of Mount Sharp. Wind and sand dunes helped carve the crater and its central mountain into what it is today. The Greenhue pediment is a long, sloping plain that cuts across horizontal layers of Mount Sharp, Vasavada said, and scientists want to understand how this area formed. It's also near another point of interest, called the Getty's Vallis Ridge, which may have been created when debris flowed down the mountain. Curiosity captured a 360-degree panorama on March 23 of the gator-back terrain. Curiosity sticks to the lower foothills of Mount Sharp, but the perspective from the ridge would have been a way to study material from the upper portions of the. From a distance, we can see car-sized boulders that were transported down from higher levels of Mount Sharp, maybe by water relatively late in Mars' wet era, Vasavada said. We don't really know what they are, so we wanted to see them up close. Fortunately, Curiosity will get another chance at this area in about a year's time from a different vantage point. For now, the rover is plotting a new course to continue its exploration of Mount Sharp, climbing down to a transition zone where a clay-rich area meets with salt minerals called sulfates. These clay minerals formed when the mountain was wet, and the salts formed as the climate dried up. Curiosity had previously studied these layers but abandoned the investigation to reach Greenhue pediment. This latest twist in Curiosity's journey, to return to a productive investigation, is a silver lining, Vasavada said. It was really cool to see rocks that preserved a time when lakes were drying up and being replaced by streams and dry sand dunes, said Abigail Freeman, Curiosity's deputy project scientist at JPL, in a statement. I am really curious to see what we find as we continue to climb on this alternate route. Seeing evidence for this major change in the Mars climate, from the wet era to the dry era, would be a fantastic feather in the cap for Curiosity, Vasavada said. And studying the layers shaped by water could help scientists understand if microbial life could have existed on ancient Mars. Fortunately, Curiosity is up for the task. What began as a 2-year mission will celebrate its 10th anniversary in August.